the President of Ratchamongkol University of Technology, Krungthep, the Director of Research and Development Office, the researchers, chairs, and all distinguished guests. Welcome to CreTech 2018, the second national and the sixth international conference.
Before we start, let us introduce ourselves. I'm Pattaya Panpitawi.
And we Pada Suthirod. We are honored to be the MCs for today's program.
First of all, may I invite Dr. Sukit Nitinai, the President of Ratchamongkol University of Technology, Krungthep, to give the welcome and opening conference speech to all of us. Please welcome Dr. Sukit.
On behalf of CreTech 2018 Organizing Committee, I am honored and delighted to welcome you to the 6th International Conference and 2nd National on Creative Technology here in Pattaya, Chonburi, Thailand. We presently welcome once again all the researchers and developers to share their experience and ideas through research talk and presentation from diverse fields in creative technology. This event has offered a platform in bringing together a forum for students, postdocs, and established researchers to exchange their ideas and contributing an integrative approach to creative technology, tourism, and education research. This conference provides a forum for accessing to the most up-to-date and reliable knowledge from both commercial and academic worlds, sharing best practice in the field as well as learning about case study of successfully integrated technologies. The meeting provides an opportunity to highlight the recent development apart from identifying emerging future area of growth. This deal with recent advance in the field of engineering, science and technology, creative technology, business, tourism, social science, and humanity, which is divided into 5 parallel oral sessions, each day for 4 rooms. We also expect to provide technical demonstration and numerous opportunities for informal networking. The success of the conference is ultimately dependent on all the people who have worked with us in planning and organizing both the technical program and supporting social arrangements. In particular, we would like to thank to the program chair for their smart advice and brilliant suggestions on organizing the technical program, the program committee for their thorough and timely review of the papers, and also our sponsor, including of the Parent and Teacher Association of Ratchamongkol University of Technology, Krungthep, UK Engineering and Supply Company, Technic Krungthep Alumni Association, Thai Public Company Limited, IRC Technology Company Limited, C Minor Integration Company Limited, WIP Electric Company Limited, Aeronautical Radio of Thailand Company Limited Mrs. สุดาดวงเรืองจิระ Inbox Outbox Company Limited Supreme Distribution Thailand Company Limited Emake Company Limited Incot Design Company Limited ดอยช้าง Marigo Technology Company Limited who have helped us to diminish the cost of CreTech 2018 for all participants. We are also very proud to welcome our distinguished keynote speaker, Mr. Abhisit Vechachiwa, the former Prime Minister of Thailand, will share his experience in the topic of social and community of Thailand 4.0. In addition, Professor Kenji Shinosaki and Associate Professor Dr. Motomichi Yamamoto from Hiroshima University, who will give a lecture in the topic of state of the art and future metallurgy and welding research technology in Japan under Industry 4.0. With your continuing contribution, the 6th International and 2nd National CreTech 2018 will certainly go to become a leading annual conference in the field of creative technology. We would like to say thank you again to participate in the CreTech 2018 conference. I hope that you will enjoy all of the forum and activities that we have offered. Thank you again.
Thank you very much, the President, for the opening speech.
Next, for morning session, we've got two keynote speakers. The first one is the person all of us have known very well and really appreciated for a long time, Kun Abhisit Vechachiwa. But before I invite Kun Abhisit, I would like to give you his brief biography. After Master Abhisit Vechachiwa finished his kindergarten at Yukonthorn Kindergarten, he studied his elementary level at Chulalongkorn University Demonstration Elementary School until Prathom Siksa 6. Then he moved back to England to study in Scatfield School and attended Eton College in high school level.
Kun Abhisit earned a bachelor degree in philosophy, politics, and economics, first-class honor from the University of Oxford, and a master degree from St. John College, Oxford. After coming back to Thailand, he received a bachelor degree in law from Ramkhamhaeng University and taught at Chulajomkao Royal Military Academy, Nakhon Nayok, and Thammasat University, Faculty of Economics. He was once a special instructor at the University of Oxford in 1989, and in 1990 he became a lecturer at the Faculty of Economics, Thammasat University.
For his political career, Kun Abhisit launched his early political career as a volunteer electioneering for Kun Pichai Ratakul in Klong Toei district, then helping Kun Chuan Likpai to deal with economic development plan before becoming a Bangkok member of parliament for the Democrat Party in 1992 at the age of 27, and was promoted to Democrat Party leader in 2005. He became the 27th Prime Minister of Thailand from 2008 to 2011 at the age of 44. He was the country's youngest Prime Minister in more than 60 years.
Kun Abhisit will give us a speech in the title of Social and Community 4.0. Please give a big hand to welcome our keynote speaker, Kun Abhisit Vechachiwa.
Mr. President, distinguished participants, ladies and gentlemen. Let me first of all congratulate the UTK for holding this international and national conferences on creative technology. Especially pleased to see the engagement with the academic world and the private sector on a topic which is very important for the future development of the country. I'm especially pleased because about 7 years ago, we initiated the creative economy policy, where we believe that the future of the Thai economy and of the country depends on our ability to increase value through technology and creativity. So to see a university that has attached importance to the use of creative technology is especially pleasing for me. Let me also at the outset welcome those of you who've come from abroad. Welcome to Thailand. And I hope that during my talk I will be able to give some perspective on what creative technology is going to mean for all of us. I have to say I'm not an expert in technology, but I hope to provide a perspective of someone that is a policymaker and needs to address the opportunities and challenges that arise from the use of new technology, especially the impact on the economy, on society, and even in politics. What I hope to do is perhaps to give you my perspective on what I see as the new technology, assess the impact of that technology on our lives, our behavior, and the implications that the technology and the changes that it brings has for the economy, for our society, and also on politics. And then perhaps identify what I see as some key challenges and policy issues facing us. Over the last couple of years, I think all seminars in Thailand would have the word 4.0 attached to its title. That obviously is because this is an important initiative of the current government, and I support fully the idea that we need to be aware of the need to change the way we do things so that the country can attain a higher status economically and also able to lift the quality of the lives of our people through the use of technology and value creation. Unfortunately, having traveled up and down the country, while everybody is aware of the 4.0 initiative, very few people actually say they understand what the 4.0 means. And it is, I think, unfortunate that we haven't had enough publicity on the thinking and the trends and the technology behind this 4.0 initiative. It's also, I think, unfortunate that the way the government has framed the 4.0 by using what they see as stages of development of the country. So they say 1.0 is the agricultural agrarian society, and then light industry for 2.0, and then heavy industry for 3.0. I say it's unfortunate because it makes it difficult for people to understand what 4.0 means. From my understanding, the number 4 was chosen to actually mimic what the whole world calls the 4th industrial revolution. So actually it wasn't about transforming from an agrarian society to an industrial society to a post-industrial society. It's more about the available technology to mankind. So 1.0 was about the introduction of machines. 2.0 is about electricity. 3.0, of course, with computing and the internet. And what we see as this wave of technology is, for me, about the integration of the various technologies, resulting in the Internet of Things, blockchains, and also other new technologies. Now, obviously, whenever we are faced with a new technology, we feel that technology brings benefits in terms of facilitation, making us do things more easily, more conveniently, and also efficiency. We can do things more cheaply. There will be cost cutting in a number of activities that we engage in. But for me, with the 4.0 technology and the new technology, there are also distinctive characteristics. That means that the changes that we are going through is more fundamental than some of the changes that have been brought about by various waves of discoveries and technologies in the past. And as I said, my talk will focus more on the social aspects or on the impact that it has on society as a whole. I think this is important. And let me just give you maybe 3 quick examples why we also need to link technology to policy issues and to how we should deal with the opportunities and challenges. So just let me take one example of the impact on society. In the US, there has been so much debate about gun control. On the 1st of August, this debate is going to be faced with a huge challenge because the court has just ruled that as of August the 1st, people who have blueprints for 3D printing will be able to actually upload the blueprints for people to download, and therefore if they have access to a 3D printer, they will be able to produce their own guns. Now, that's technology. It's allowing people to use materials to create various things from 3D printing technology. But the impact on society will be profound because it clearly changes the ease and the availability of guns and throws up a big issue about how guns could then be regulated. Again, you may have all the technical knowledge, but if society, if the government does not know how to deal with the impact of such technology, we do not really know whether this technology is going to create more benefits or more harm to society. That's just an example of how the impact of new technology is going to have on society. Take economic policy. One of the, I think, poster child of new technology in business would be Uber. And in Thailand, we have a very curious situation where we talk about a 4.0 initiative. Uber remains illegal. And at the same time, Uber is now going to be merged with another company, Grab, which will create a monopoly in terms of this industry. And it seems that nobody is taking any action. A similar merger is taking place in Singapore, and the Singaporean government has been very clear that it will not allow this merger to go through if it creates monopoly power. Again, you have new technology, you have new businesses, you have new opportunities, but at the same time, you also need policymakers to be able to understand the impact and come up with an appropriate solution. A third, final example, now in the realm of politics. Modern political campaigning now relies very much on data analytics and also on micro-targeting of voters. That is all very well until we see what happened in the last US presidential elections, where we have, number one, continuing investigations on how a foreign power actually hacked the data in the US elections database, interfered with the elections, influenced the elections. Those investigations continue. At the same time, we also had the issue of how that campaign was also conducted, whereby a company, Cambridge Analytica, actually people see as violated privacy and private data, working with Facebook, and then use that data for political purposes. So once again, technology is moving ahead. It is enabling and allowing us to do things in a more efficient manner, but it also creates a number of issues that need to be addressed by policymakers in order to make sure that the new technology is put to good use. So I come back to what I see as the fundamental difference between this new wave of technology and where we should begin when we want to think about the appropriate framework of how this technology should be used or regulated in our society. I mentioned already one of its nature, which is integration. So various innovations and technologies from different fields will be combined to create new opportunities. The second thing, of course, is that the availability and accessibility of the current wave of technology is much more widespread than in the past, notably through our use of mobile phones as platforms for many, many things. And of course, it goes without saying that there is also a disruptive nature of the new technological change. All technologies naturally are disruptive because it's replacing old technologies, but the degree of disruption that we will see from this wave of technology will be much, much more widespread than in previous times. What does that actually mean for society, for our country, and for people? Well, I guess the first thing that we should not forget is how much our lives and our behaviors have changed over the last few years. Just the use of mobile phone. We now have more telephone numbers than people in this country. So we also have now a rapid growth of smartphone penetration. So a few years ago, many people would say, well, this technology is only available to urban people, to well-to-do people, but now the degree of penetration is growing very, very rapidly, so that most people will have access to this technology. So just the amount of time we spend with our mobile phones now, and what we do with the phones. So issues ranging from payments to the way we communicate and exchange information and others with each other very much depends on this platform. And what may seem like something that is unthinkable only 2-3 years back could easily become the normal way of life. A number of Thais who have recently visited China have been surprised by the degree of electronic payment, and which is driving out the use of cash very, very rapidly in China. In Thailand, maybe 4 or 5 years back, we would think that electronic payment would be confined to just only a small group of people. But now, for instance, our welfare system, you know, the card for low-income people, that payment is all done electronically. And also the introduction of prompt pay and the use of that is widespread. So our lives have been changed. You just need to examine your own behavior day to day to see how our lives have been transformed by this technology. But more important than that, the technology is changing the way we relate to other people and changing the relationship between us and the government and the state, which throws up a number of challenges and problems that we need to address. Transactions are now carried out electronically, so we need to somehow be able to create the confidence for people to use that technology, at the same time be able to deal with any criminal activities online. And if we get the balance wrong, we will either not be able to benefit from technology, or we will either allow all the damages or harm that comes with the technology to actually dominate. So for instance, one issue where it is clear that we're still not getting the balance right is the fact that while we talk about moving the country to 4.0, one of our most famous laws around the world is the Computer Crimes Act. Both the private sector, both rights groups and others feel that our Computer Crimes Act simply does not really conform to the demands of the new technology and how we should be able to use and benefit from it. And there will be so many more challenges for the state and for the government. Obviously, the government needs to address security challenges that come, but what is the right way to address the security threats? As I said, the Computer Crimes Act is being used at the moment, but I think for most people who have studied the issue, nobody really believes this is the way to deal with the kind of challenges, that problems that we face. How are we going to deal with the issue of electronic payments and now cryptocurrencies? Do we allow a lot of freedom and run the risk that some people will be exploited by people engaging in these businesses? Or do we try to regulate it? Now the government is going to tax ICOs, which means that for me, ICOs will probably not take place in Thailand, certainly not on the market, because why would they want to pay 15% tax when they can do this tax-free outside of Thailand or outside of the market in an informal economy? So the changes that are brought about by the relationships between people and organizations and people in the state will throw up fresh challenges that we need to understand and address. Obviously, the benefits should outweigh the costs and the damages. And there is no doubt that the new technology is creating fresh opportunities for everybody. And this is easiest seen in the realm of business and the economy, where there is likely to be a growth of new businesses and new sectors that can create value and contribute to economic development. There will be new services, particularly just through the cutting of the middleman, because the new technology allows people to be in touch and contact each other directly, and therefore reduce the cost of having to go through an agent or a middleman, which is why we see so many new businesses that simply just allow people to use technology and applications to bypass the old ways of doing business. But this benefit is coming along with what I already said, the disruption of many things. Clearly, it's replacing a number of old businesses and old business models. It's also likely to eventually disrupt the way companies and firms are organized. So the trend that we see is that big organizations or producers who will use every single part of the supply chain within one organization is unlikely to be able to compete with organizations that simply source and outsource to the most efficient and competitive and even innovative producers. So that's clearly going to disrupt the way business is organized. And it also creates new aspirations for the younger generations. We will see, we already see that young people today are more interested in becoming independent entrepreneurs than being employees of larger organizations. And they feel that they can be independent entrepreneurs, try their hands at a certain business, have enough mobility to move out if either they fail or even if they feel that they've already achieved their goals, even at the age of maybe 30. So all this is changing society at a fundamental level. I do believe that on the whole, this will spur economic growth. This will provide better services. So just in two areas where I hope to see the potential of new technology being used, which is health and education, where we can clearly provide far better services and higher quality for most of our people in the realm of health and education. And even in politics, the technology should allow much greater engagement from people in public affairs. But while these benefits are substantial, we also need to be able to deal with the problems that come with disruption and with the changes that the technology brings. So there are a number of issues that I feel we need to address head-on to make sure that we use this technology as best we can to serve our people. And the first is that the ability to create value that comes with a new technology should somehow be used to relate to our strengths and to address our weaknesses as an economy and as a country. The reason I don't much like the way the government has framed the 4.0 is it makes people feel that somehow the agricultural sector is going to be left behind. Actually, if we want the new technology to benefit our people most, we should somehow see how the new technology is going to serve to increase the value of our agricultural sector. And there are huge opportunities in terms of food production, because food security is going to be one of the most important global challenges as we move to the future. And the potential for the increase in value from our agricultural products is huge. In a way, that's because our agricultural sector is still very, very inefficient. So even just the production, the process of production, there is so much room to improve efficiency and to improve output. But to move further using technology so that we actually increase the value of our products, I think that is that has great potential, and we need somehow to make people and society understand that the new technology could be very much used to lift the agricultural sector, almost like another revolution, another green revolution, if you like. That would certainly address the issue of the quality of lives of most people in Thailand. Similarly, our services sector, our tourism sector, can also benefit from the new technology. So I think there needs to be an understanding among people at large that the new technology is not a sector in itself. It's not about computers, internet, blockchains for their own sake. But these are tools that can transform the agricultural sector, the tourism sector, and other services. That is how we will get the most out of technology in order to lift the country and our economy towards our aim, which is to be a high-income economy. Now, to be able to do that, one of the biggest obstacles that we need to overcome is the issue of our laws and regulations. The fact that Uber is illegal, I think, is very illustrative of the problem that we have. And meeting so many young entrepreneurs, what I find is that whenever anybody tries to do something truly innovative, they find themselves in trouble with Thai law, because what they will be doing will probably violate certain outdated laws that do not allow them to create this new business. So there needs to be a comprehensive review of existing laws to allow innovations and to allow new business sectors to grow. And equally important, there is the need now to change the way we write laws. I'm surprised that 3 years ago, the current government actually sets up a special task force to deal with this issue. They actually want to reduce the number of laws and regulations along the line that Korea has done. Korea reduced its laws, the number of laws and regulations by about a third, almost a half, because most of them are outdated. Well, we've had this special task force set up by the government for, I think, 2 years now. But actually, the current government has put in about 300 new laws through the National Legislative Assembly. And most of the laws are still written in the same old way, which is it grants more power to government agencies, ministries, departments, so many licenses, so many permits that you still need to apply for. This kind of law and regulation will not be able to support the business sector if we want the sector to benefit from the technology and innovations. So for me, probably the most important policy issue and one of the quick wins is we need to revamp our laws and review the way we write laws or we draft laws. The second issue is, and this is related to the wider economic trends, not just in Thailand but in the world, is that we need to address the issue of inequality. And we need to be careful to assess the impact of the new technology on the issue of inequality. We had hoped that the new technology would actually provide access for everybody to information, to knowledge, and so on, and therefore will help to contribute towards a more equal society. But if you look at the trends in the economic structure of Thailand and also of other countries, you will also find that because the new technology is so much dependent on networking and on the use of volumes of data and the need to deal with logistics, these factors, these sectors become natural monopolies. So people who control the networks, who own the assets that make up the networks, tend to be able to appropriate all the benefits from economic growth. So it's hardly surprising that in Thailand now, we see that in the energy sector, telecommunication sector, retail sector, there is far, far greater degree of monopoly now. And that monopoly is creating a very unequal economy. And therefore, that's something that we also need to address. We also need clearly to be able to protect ordinary people and consumers better because of the exploitation through new technologies. Various schemes that are scams that have exploited a number of poor people have been much, much more prominent in recent times. So again, this agenda of the need to be able to deal with these issues, whether it's through competition policy, a greater degree of transparency, and a very active campaign of public education is also necessary. Related to this, and this will be an even bigger problem down the line, is that technology is likely going to displace people and resources. So, for instance, not far away from here, we will be setting up the EEC. And there are a number of new investors and technologies that the government hopes to attract from outside. One of the things I'm sure you will see is that the new EEC is not going to be the same as Lam Chabang and other industrial estates. That is, you will not see much in terms of jobs creation, because most of the new industries will probably be capital intensive, use robots, use artificial intelligence. And we will also see a lot of displacement of people from a number of jobs in a number of sectors. Now, it may be a fortunate thing that Thailand is also becoming an aged society, and there is a lack of labor or a labor shortage. So machines and robots might help to resolve some of that problems. But you still need to be able to address the issue of people becoming unemployed and displaced from their jobs, and how they can acquire the new skills that are necessary for them to be able to earn income. In any case, it is clear that there is a threat to the concept of job security for most people with the new technology, which means that there are two things that the government has to be better at. Number one is reskilling people, and number two is to provide some kind of social safety nets. Now, for countries that have faced these issues of technological change and also an aging society, most of those countries tended to have a fairly good welfare system in place. Even then, their welfare systems have come under a lot of pressure in terms of the viability, in terms of finance. But for Thailand, we are going through this transformation, this change, while our welfare system is really underdeveloped. So this issue of job security and income security will be very important. And to have a more extensive welfare system, you need to be able to have the ability to collect revenues and taxes. But that in itself is also being threatened by technology. I think the revenue department people are still scratching their heads. They say they want to collect taxes from e-commerce. I'm not so sure how they're going to do it. And the reality at the moment is that for big multinationals who are operating here, doing a lot of businesses here, are almost paying no taxes at all. Just take the advertising industry now. Most of the advertising revenues now go to the big players, Google, YouTube, Facebook. The Thai government hardly collects or is able to collect any taxes from these players. And for me, to overcome this problem, there needs to be a greater degree of cooperation among governments to see how we deal with this. I would urge the Thai government, since we are going to assume the chairmanship of ASEAN, that it is time for ASEAN to take up these kinds of issues. Because as individual countries in the Southeast Asian region, we cannot have enough bargaining power to deal with these big multinationals. But as a bloc of 10 countries with about 700 million people, I think we have a chance of being able to deal more effectively or bargain more effectively with these big multinational players. The other thing that I would mention is that what we should also try to use technology for is that, yes, people are going to be displaced from their jobs, and yes, we will have a huge reduction in the requirement of manpower in a number of industries. But it also provides an opportunity for us to redeploy our people in the social services, which will continue to need more and more people for care for the elderly, for the health sector, and for education. And I think what we should support is the growth of social enterprises that use new technology to provide these services. So we should come up with some kind of social contract, if you like, whereby people who are interested in engaging in these activities through a model of some kind of social enterprise will have the incentives to do so. So we shift a number of resources away from sectors where machines and robots can do things better than us, to sectors where the need for human touch remains. And there will be valuable services as well, as I said, because we are moving towards an aged society. Finally, just moving to politics, the technology is changing people's political behavior and people's political engagement. Most people now take their information from social media. The mainstream media is having its influence reduced. But this change in behavior also contributes to two problems. One is polarization in our societies, because as we are able to choose what kind of information we consume, we have this tendency to just look at the information that confirms our beliefs. And we have less tolerance for people with different views. We just ignore those, we cut them out from our social circles online, and so on. That is dangerous in terms of polarization and conflicts. The second problem, of course, is that technology and social media make us far less patient and make us lose our concentration. And one process which is very important for a healthy political system is deliberation. And if technology makes us deliberate less, so we simply react to issues just on our instincts, what we like, what we don't like, what we support, what we don't support, that is not healthy for policy formulation, that is not healthy for the political process or democratic process as a whole. So I will end with this, that with all the challenges that we have, the most important will be we make sure that our human development policy matches the needs of society which is being transformed by technology. It's about skills, it's about literacy, digital literacy. It's about how we adapt our ways in society and in communities to the use of technology without forgetting our identities, without forgetting what our ultimate goals and aims should be, which is to make technology serve us as humans and as a society and as a country. Once again, I congratulate the university for holding these conferences. There will be huge challenges. I've mentioned a number of problems, but I want all of us to be positive. Because the new technology and the changes and the innovations are providing unprecedented opportunities. Many of us in this room, in our lifetime, would not have seen the growth of opportunities that are available to us. Just think back when we were students. Just think back when we were trying to learn new things only a few decades ago. You have to find somebody who knows what you want to learn. You have to find books on topics that you want to learn. These days, you need a phone, Wi-Fi, a finger, 2 eyes, and a reasonable brain. And you can learn everything. The fact that we can do so many more things quickly, cheaply, more extensively is a cause for us to celebrate and remain positive. But while we remain positive, we just have to be grounded and realistic. Not get lost in the wave of technology and forgetting what that technology should be used for and how we should use it. So if we are aware of this, I'm sure that there are exciting times ahead of us. And if we do things right, this will be a very important opportunity for our peoples and for our country to attain a much higher stage of development and create better lives for everybody. I thank you for this opportunity.
Next will be question and answer session. So if any of you have a question and any topics that you want to know more in depth, in detail, and want to ask Kunapisit, please feel free to write down your question in a piece of paper and pass it on to us so we can read it out loud here, and then we will get some opinion and answer from Kunapisit.
ถ้าอาจารย์หรือนักวิจัยสามารถเขียนคำถามเป็นภาษาไทยก็ได้นะคะ เขียนแล้วก็สามารถส่งให้นักศึกษาค่ะที่อยู่แล้วเดี๋ยวทางพิธีกรจะรับหน้าที่อ่านนะคะคำถามเพื่อที่จะส่งต่อให้ท่านอภิสิทธิ์เป็นคนตอบค่ะ
ให้ถามสดก็ได้นะ มีเอาไมค์ง่ายกว่า
ค่ะท่านไหนถามสดก็ได้นะคะเดี๋ยวทางพิธีกรจะส่งต่อไมค์ให้นะคะยกมือได้เลยนะคะ
How do you feel the America First policy will impact Asian economies as a whole?
Okay. Well, first of all, I hope the policy will not last long. Because it's a threat not just to Asian economies, it's a threat to the global economy. Obviously, as a politician, I can understand the current wave of nationalism and extremism that arise, mostly because of the problem of inequality. But for America, which is a superpower and a world leader, to now use a policy that denies its obligations and commitments on multilateral agreements is extremely dangerous. Economically, there is absolutely no justification for saying that if you trade with somebody, you have to run a trade balance or a trade surplus. But that's what America First is being used as. So the US is now compiling a list of countries that run surpluses with it and taking trade reducing measures. And sure enough, they are facing retaliation from China, from the European Union. And therefore, there will be a trade war and global reduction in trade, which will hurt everybody. Actually, only a few days ago, the US is now discovering that it has a huge stockpile of meat because of the retaliatory measures taken against the US. So I hope somehow that this policy is going to be reversed. Otherwise, much of the gains that the world has had from globalization and international trade will be undone. And if it escalates, you only need to look back to the 1930s to see what that could lead to.
Okay, thank you. Thank you.
Yes, that's according to that, you mentioned that there are many opportunities provided that the new technology are largely used to help solve issues that an organization is helping processes, improving efficiency and so on. That, what do you think that, how the technology is powering up new solutions that's global challenges today, and what is you think about in the term of the Thai education today?
There are a number of things about education and need to. I now don't really want to use the word reform because everybody's sick of the word reform. We need to completely upgrade or whatever our education system. There's an opportunity. Technology will help. The most important thing, though, is about the need for us to change the learning process in our education system, right? I mentioned before that when I was a student, I had to go to school, I had to go to university, otherwise I wouldn't have knowledge, okay? But today, you don't need schools and universities for knowledge. You need schools and universities for skills. So you have to start with changing the whole learning process in the education system. Technology will be part of that change, but I think that's the most important thing. And to be able to do this effectively, obviously you have to change the curriculum. You have to change the way we assess education outcomes. But I think there are also other factors that will help contribute to these changes. Number one is that actually now the number of children and people who attend schools and universities will be reduced. We can focus much more now on the quality and the process, because much of the problem in the past has been we had to drive to increase opportunities, increase the number of seats for a growing population, especially young people. But now we can concentrate much more on the learning process and on quality. And technology can be used in various ways. E-learning will be a very important way to help provide access and also to create better and more equal opportunities for people to learn as well.
All right, that will be the end of the session, and it was a very informative and inspired session. Thank you very much.
May I invite Dr. Sukit Nitinai, the President of Ratchamongkol University of Technology, Krungthep, on the stage to present the token of appreciation to Kun Apisit ค่ะ
And may I invite board directors and executive members to take a group photo with Kun Apisit up on the stage.
เชิญคณะผู้บริหารนะคะถ่ายรูปกับท่านอภิสิทธิ์นะคะ invite Professor Motomichi Yamamoto on the stage to take a group photo
with us.
Ladies and gentlemen, for the next morning sessions, we got another keynote speaker, Professor Dr. Motomichi Yamamoto. Before I invite our keynote speaker, I'd like to give you his brief biography. Professor Dr. Motomichi Yamamoto graduated his bachelor, master, and doctoral degree from Faculty of Engineering, Hiroshima University. He is now an associate professor at Graduate School of Engineering, Hiroshima University, and he is in charge of primary major programs, mechanical system engineering.
Professor Motomichi will give us the speech in the title of State of the Art and Future Prospect of Research on Welding and Joining Technology in Japan. Please give a big round of applause to our second keynote speaker, Professor Motomichi Yamamoto.
Thank you for your introduction. Good morning, ladies and gentlemen. I'm Motomichi Yamamoto from Hiroshima University, Japan. First of all, Professor Kenji Shinozaki, President of Japan Welding Society, had scheduled to give a presentation here, but due to poor physical condition, we are very sorry just before the cancel. So I will speak on his behalf. So it is my pleasure to be here to talk to you. So today, I'd like to talk about the state of the art and future prospects of research on welding and joining technology in Japan. There are outline of my talk today. Firstly, I introduce manufacturing industry in Japan. So background, the concept of Society 5.0 and Industry 4.0 by connected industries, and progressing field of fourth industrial revolution in Japan, and introduction of smart manufacturing and at the viewpoint of welding as example. Second, future vision of welding and joining technology, development of simulation technology for guaranteeing welding performance, and development of new materials and its joining technology for multi-material application for vehicle weight reduction, and development of technology for predicting life and prolonged life of large welded structure like bridge and large size scale ship. And I'd like to show activities of Japan Welding Society because Professor Kenji Shinozaki is the president of the Japan Welding Society. Finally, I'd like to show introduction of recent researches on the welding metallurgy field. Firstly, this left graph shows a composition ratio by industry in GDP in Japan in 2015. Industries are classified as manufacturing, service, retail, and others. In this composition ratio, manufacturing industry is about 20% and highest in Japan. In comparison of major countries of the ratio of manufacturing industry to the number of employed people, Japan is about 60% in 2014. This value in Japan is less than China and Germany, but still high. As you noticed, Japan is supported by the manufacturing industry and people working there. This graph shows trends of the performance of the manufacturing industry in the last 5 years in Japan. You see, it is not good. This depends on the following factors. Excessive appreciation of the yen, high corporate effective tax rate, delayed response to the economic partnership agreement, severe environmental regulation, and energy cost increase, labor regulation, manpower shortage. So, Japanese manufacturing industry must get out of this situation. Industry 4.0 is a concept announced in 2011 as a national strategic project in Germany. This means fourth industrial revolution. We have already experienced the industrial revolution from first to third. Yes. With the advent of AI, IoT, big data, it is possible to realize a society that seems impossible until now. Along with this, the possibility that the industrial structure and employment structure will change dramatically. That is announced the concept of Society 5.0 and connected industries. Fourth industrial revolution support to create Society 5.0 through by connected everything. Due to create a new society which is human-centric and solution-oriented, we want to solve social challenges such as aging society, labor shortages, environment and energy restrictions, and so on. Progressing fields of fourth industrial revolution in Japan are as follows. First, automatic learning of trucks, mobile service by automatic and manned mobile traveling. Second, robot and drone. Manufacturing, nurse care, medical, agriculture, infrastructure, disaster response, and construction. Third, smart manufacturing. This is important in this presentation, smart factory. And model-based development, especially in automobile company in Matsuda. And finally, space industry, so service utilizing satellite system. Today, I focus on the smart manufacturing. This is an image of solution using digital tools in manufacturing industries. The concept of smart manufacturing is that in order to improve productivity in supply chain and engineering chain, data utilization using digital tools must be expanded and speeded up and quickly reflected customers' utilization data in the supply chain and in planning and design in engineering chain. Then to create new added value for customer, such as predictive maintenance, remote maintenance, operational optimization, new services, and so on. This is an example of smart manufacturing system in Komatsu, which is the biggest company in Japan as a construction machine manufacturer. Komatsu started up manufacturing innovation cloud system called ComMix as this image. Product design and manufacturing process are made on a computer, and these data were saved in ComMix in cloud. At the same time, all manufacturing processes such as heat treatment, machining, welding, and assembly, and shipment are controlled by ComMix, considering yield and quality of product. As a result, this company, Komatsu, has achieved productivity twice. For example, in the part of welding, control welding conditions and robot using LAN, and then replace parts just before error occurs. Control welding current to suppress the occurrence of defects. This company is targeting to connect all robots of all factories all over the world by LAN within 2018. Changes in the times and the environment surrounding manufacturing are globalization, lack of engineers and researchers. From product to service, open innovation and open science, sustainable, stable growth, and safety and security. So we must realize a super smart society for future industrial structure and social change. What is the goal of future welding and joining technology in Japan? First, to clarify and systematize instability possessed of the welding process from a scientific point of view, and to make welding and joining technology get out of special process, and to develop manufacturing technologies that considers resources, energy, and the environment. Strategically, priority issue is strengthening the foundation for manufacturing, academic research, and basic research. So, systematization of next generation welding and joining science, and innovation of welding and joining technology to keep leading the world. Evolution of welding and joining technology for building sustainable circulation society with a safe and secure. As an example of innovation of welding and joining technology, I want to introduce the national project in Japan concerning development of simulation technology for guaranteeing weld performance. This goal of this project is that the performance of the final joint can be guaranteed only by setting the material and process conditions, or optimize materials and process conditions from required performance by using AI and IoT technology. In this project, development of prediction technology of weld pool formation using arc model and 3D weld pool model in computer, development of prediction technology of properties of weld zone, such as hot cracking, microstructure of weld zone, concerning phase transformation, and development of prediction technology of weld joint performance, such as ductile strength, fatigue strength, are all connected. This is another national project in Japan. The project is multi-material application for vehicle weight reduction. In this project, not only to develop materials for both high strength and good formability, including specific stiffness and specific strength, but also to develop design, manufacturing, and quality assurance technology for multi-materialization using all kinds of materials. For manufacturing, welding and joining technology is very important. For example, joining of ultra-high tensile strength steel, joining of dissimilar joints such as metal-metal combination or metal-CFRP combination, using conventional joining technique, adhesion mechanical joining. We must develop technology for predicting life and prolong life of large welded structures for maintenance of infrastructure. There are many infrastructures such as a bridge, chemical, and energy plants. Therefore, we have to develop technologies of life prediction and repair welding of aged, deteriorated welds. Also, develop welding technology of ultra-huge steel structure, such as large ocean structure, a huge steel ship. High efficient, high reliability welding technique and ensuring the arrest performance to brittle fracture of extremely thick plate are required. On the other hand, micro and nano joining for electric device, micro machine are also required. I have talked about the current status of Japanese manufacturing industry, especially welding and new initiatives for the future assuming industry 4.0. The pointing out of these problems and the further strategies were actively discussed at the Japan Welding Society. So I will introduce about Japan Welding Society, JWS. We had discussed roadmap of welding research in Japan until 2040, almost 8 years ago. This figure shows a roadmap until 2040 as a function of technology level. We thought that the main direction for realizing a safe, secure, sustainable society is material integration technology. And the goal of joining may be completely bonded without recognizing joint. That's to say, to develop joint-free and integration technologies. By using these technologies, we will achieve strong earthquake-resistant structure, resource saving, energy saving, and longer life of structures. In order to achieve such a goal, element technology and understanding phenomena, smart welding technology, advancement of in-situ observation technology, multi-materialization, and composite materialization were developed by 2020. We will aim phenomena modeling of element technology and develop novel joining technology by the following 2030. Japan Welding Society was established in 1926 as Electric Welding Association. Then, the association changed its name to Japan Welding Society in 1943. So JWS has over 90 years of history. Mission of JWS is to contribute to the progress and development of human culture by promoting science and technologies of welding and joining. The organization of Japan Welding Society has the following general meeting: Board of Directors, 9 branches, and the Strategic Planning Committee under the Board of Directors. Board of Directors in charge of each administrative issue and decision making, some of which shall be approved by general meeting. 9 branches exhibit activities specific to each district. Strategic Planning Committee plays key role to activate all academic activities of Japan Welding Society, including research promotion, publication of papers and articles, holding annual national meetings, and international conferences, and so on. There are 10 committees for management and 8 committees for generic research and specific research. The mission of Japan Welding Society is as follows. So, integration of engineering, information and communication, training and education, promotion of science and technology of welding and joining. In order to achieve such missions, we do various activities as shown in these figures. The technical areas that the Japan Welding Society addresses are classified into the following 3 areas. That's to say, process, metallurgy, and structural design and performance evaluation. In the process fields, many kinds of welding processes during welding, overlaying, surface modification, additive manufacturing are evaluated at the viewpoint of elucidation of phenomena, optimization, sensing and controlling, automation, and so on. We are conducting research on welding and joining of materials, such as resin, composite material, ceramics, and so on, from the viewpoint of metallurgy, as well as ferrous and non-ferrous metal materials. And prediction and control of microstructure and properties in weld zone and other following researches are studied. In structural design and performance evaluation, strength of welded joint, life, distortion and residual stress are evaluated as following items. One of the main activities of Japan Welding Society, providing a form fair state-of-the-art knowledge and technologies in welding and joining, are presented and discussed in annual meetings held in the spring and autumn. Oral presentations in the spring and autumn are normally over 100 and 200, respectively. In addition, forum, symposium, special lecture meetings, poster sessions, and so on are held at the same time. Articles and papers were divided into different journals. First issue was published at the established year of Japan Welding Society, 1926. Articles and papers, 12 issues a year, has been published from 1943 to 1983. Since 1983, articles and papers have been separated, and articles are published 8 issues a year, and research papers are published quarterly a year. And now, research papers have changed to web publication since 2007. Preprints of annual meeting have been published since 1967. Now, we also publish welding letters by English. Also, international activities are as follows. So, International Welding Symposium of Japan Welding Society was held from 1971. And Japan Welding Society co-organized East Asia Symposium with Korea and China. Also, Japan Welding Society co-organized IIW Annual Assembly, and we hope next assembly in Japan will be held in 2022. In Japan, Japan Welding Society, JWS, and Japan Welding Engineering Society, JWES, are different organizations. So JWS reveals the academic field of welding, and JWES deals with welding technology and engineering. We have started collaboration between JWS and JWES since 2016. Next, I'd like to show the state of the art and the future prospects of research on welding metallurgy in Japan. So because Professor Shinozaki is a specialist in the metallurgy of welding. In 2010, the future plan in Japan Welding Society was discussed through whole 8 generic research committees. At that time, in the Committee of Welding Metallurgy, we discussed the roadmap for research in welding and joining and the following philosophy. First, to construct a sustainable, stable, and growth society, to construct a safe and secure society, through to produce sound and high-performance welded joint. Second, to innovate welding and joining technology, through to weld the next generation materials and to develop new welding and joining process. Third, to pull out of welding and joining technology called special process, remedies for shortage of welding engineers and researchers, through to sophisticate and systematize material science of welding. We discuss now to realize each technical issue, which is to produce soundness and high-performance weld joint, for example. Then we set the following technical targets. First, realization of weld cracking and defect-free joint. Second, improvement of welded joint properties, such as high strength, high toughness, and high corrosion resistance. Third, improvement of the reliability of the weld repair and maintenance technology. So hereafter, I will introduce the recent researches on welding metallurgy in Japan regarding some technical issues. In the recent researchers, there are three main approaches to research. First, in situ observation method, in order to understand phenomena precisely. Second, modeling and simulation, in order to predict phenomena. Third, dissimilar welding and joining, in order to take advantage of multi-materials. I will introduce representative researches based on the above approaching regarding three technical issues in this table. At first, regarding the technical issue of realization of weld cracking and defect-free joint, I will introduce the research of development of filler wire for HT 980 high tensile strength steel welds without preheating. And also, I introduced hot cracking susceptibility of ultra high purity stainless steel. As you know, the demand of high strength steel increases in bridge, shipbuilding, and so on. But welding for these steels is difficult because of its high cold cracking susceptibility. So generally, when we weld these high strength steel, we use preheating before welding. But normally, this is so hard to do. This research, studied by Professor Saida in Osaka University, is to develop a filler wire for HT 980 steel welds without preheating. The new filler wire metal consists of ferrous, chromium, nickel, ternary alloys in order to weld without preheating, utilizing retained austenite. This research was done by a national project program. The main chemical system is 30% chromium and 7 to 9% nickel steels. These are examples of microstructure of NR2, NR4, and NR5. Typical microstructures consist of delta ferrite, retained austenite, and martensite. That's say these are triplex stainless steel. Main matrix microstructure is martensite and retained austenite locates at the cell boundary. And delta ferrite locates intra or intercell boundary depending on solidification mode. Consequently, 13% chromium and 9% nickel and 0.03% carbon steel containing 35% retained austenite was decided as a new filler wire for HT 980 steel without preheating. In terms of tensile strength, toughness, hot cracking, and cold cracking susceptibility. Professor Saida also made clear the effect of retained austenite on cold cracking susceptibility theoretically at the viewpoint of diffusion of hydrogen. This is also Professor Saida group research. The impurity elements such as phosphorus and sulfur affected solidification cracking susceptibility is well known. He made the tentative stainless steel based on type 310S stainless steel, bearing of phosphorus from 7 to 260 ppm, and sulfur from 1 to 280 ppm, carbon from 6 to 300 ppm as shown in this table. Then carry out the transverse strain test for cracking for all specimens. The BTR brittle temperature range is affected by carbon, phosphorus, and sulfur content as this figure. The potency atomic factor for enlarging BTR is defined as the gradient of this line. So sulfur is most effective element for enlarging BTR. That is to say, most determinantal element for solidification cracking susceptibility in type 310S. Also, element parameter for cracking, such as this formula, is derived for estimating BTR like this figure. Both researches suggested useful thinking for decreasing cold and solidification cracking susceptibilities. Regarding the technical issue of elicitation of metallurgical phenomena in new welding and joining process, I will introduce the research of classification of defect formation mechanism in friction stir welding (FSW) by X-ray radiography. Friction stir welding (FSW) is an updated joining technology, and many researchers are studying in the world. In this research field, it seems that the processing research is ahead of the research concerning joining mechanism basic side. I believe to make clear the joining mechanism of this process. Professor Fuji's group in Osaka University is interested in material flow during friction stir welding, and they observed it dynamically through behavior of tracer observing by two-direction X-ray radiography, very special equipment. Here you can see this equipment, and these are both X-ray photos taken from upper and bottom side. They show the behavior of tracer. So this figure shows three-dimensional track of tracer inside of the material. It is clear that the concentric plastic flow region having a predetermined width around the probe is formed during friction stir welding. These figures show cross-sections of friction stir welding and track of tracer observed by X-ray radiography using a rotating speed of 600 RPM and 400 RPM. When a rotating speed of 600 RPM is used, there is no defect, and the track of tracer is concentric circle flow pattern around the probe. But when a rotating speed of 400 RPM is used, you can see the defect at the advancing side. In this case, distance between each plot is so narrow at the advancing side. This means a stagnant flow occurs in this area, advancing side. This irregular flow causes the defect. The two-direction X-ray radiography is so important apparatus for considering material flow during friction stir welding. And Professor Fuji's group continue to produce important data using this equipment at present. Finally, regarding technical issue of visualization and modeling of metallurgical phenomena of weld zone, I'd like to introduce analysis of solidification process on arsenic stainless steel weld metal using synchrotron radiation and prediction of occurrence of solidification cracking during laser welding by in situ observation using high-speed camera. This research was done by Professor Terasaki in Kumamoto University. As you know, welding thermal cycle is rapid heating and rapid cooling. When we control microstructure in weld metal, we must understand phase transformation during welding and rapid cooling. To monitor dilatation is one of methods to detect phase transformation temperature during welding, but this method cannot detect not only at a high temperature, for example, near melting temperature, but also its microstructure change. So Professor Komizu and Terasaki developed in situ observing method in which phase transformation was detected by diffraction pattern using synchrotron radiation. This method is more accurate than the conventional method. This figure shows set-up specimen in the synchrotron radiation system. In this case, molten stainless steel is used. You can see the dynamic diffraction from weld pool during welding. This figure shows equilibrium phase diagram of 78% Fe transverse section in Fe chromium nickel system. This blue line shows this Martin-stick steel. In equilibrium phase diagram, this Martensite steel transforms from liquid to austenite phase through this phase at each temperature. On the other hand, according to diffraction data, weld metal transforms from liquid to delta plus austenite through this phase. Differences between equilibrium and welding transformation is in welding. Eutectic reaction doesn't occur and delta remain in weld metal after solidification. This in-situ observation method is useful to know phase transformation mechanism during welding. This in-situ observation method to observe around weld pool during laser welding using high-speed camera. This research was done by our group in Hiroshima University. You can see solidification cracking during welding, and moreover, high temperature strain was measured by this movie. This figure shows, right side figure shows, center figure shows the strain history between liquidus and solidus temperature, very high elevated temperature in this weld metal, which were derived from this movie. The cross marks in this figure means the point at which crack occur. Connecting these cross points, we can directly obtain this right side figure, ductility curve between liquidus and solidus in weld metal during welding. We have already developed the U-type hot cracking test, new type test method. So we can calculate strain history during U-type hot cracking test using laser welding by numerical simulation, for example, FEM analysis. Now we obtain both the high temperature ductility curve and the high temperature strain history. So it becomes possible to predict solidification cracking. In the left graph, the red curve is high temperature ductility curve measured with in-situ observation method by using high-speed camera. And the black curves are high temperature strain history and the different initial load of U-type test by using FEM simulation. You can see that the strain across the ductility curve when the tensile load exceeds 8.91 kilonewton. This means that crack is much possible to occur due to the high strain rate. The right pictures show the result of hot cracking test, actual test result. We can see that the solidification cracking did begin to occur when the initial load was over 8.91 kilonewton. We succeeded to predict the occurrence of solidification cracks in several cases using this method. Today, as time is limited, so I only introduce several researches. But besides these researches, there are many excellent researches on welding metallurgy in Japan. Also, in other fields, for example, the laser guy, arc guy, strength guy, there are many researchers in Japan. So there are many excellent research results. So I hope these researches are advanced with international cooperation. Thank you for your kind attention. Thank you very much.
Thank you very much for a wonderful talk. So will be question and answer session, and since we have limited time, I would like to have only one question from the floor. Anyone wants to ask?
Thank you very much, Yamamoto Sensei. So, my name is Dr. Ekachai Walin Silak from Mahidol University. Actually, I'm his student from Hiroshima and also Dr. Richai. So today, I'm really happy for Sensei present about the revolution of the industry and society 5.0. This is the first time for us to know about the society for 5.0. Anyway, in Japan size, so you have the big how to say, increasing about your technology side. And in our group, also in MTech or Rajamangala and Mahidol University will hold together for joy in the research. And we hope you are mentor for us. However, I would like to know about if we need some material consumption which is difficult to get in Thailand, like high ST90 or high tensile steel sheet, something like that. Could you please tell us how to obtain it from Japanese side?
Yeah. So thank you very much for your question. So now we have the big problem. So shortage of the researchers and workers also in the old type technology. So welding, casting, forming. That is a big problem, especially in university side. Disappear many laboratories. So that's the big problem. So now we try to make the structure for society to make the collaboration in Japan also. So equipment we can use Osaka University, Hiroshima University, Tokyo University. Also in near future we have to make the structural society collaborative research work with other countries, I think. So for example, our laboratory have the laser equipment or high-speed cameras or some technologies. So, and also we can get some special materials in Japanese side. So, but Japanese company have to use these materials as a product for foreign countries, for example, the Thailand side or other Asian countries. So we have to know what is the needs in these countries. So we have to collaborate also in research side. So that means you can use our equipment or knowledge, and also we want to know your knowledge and experiences. So we have to think about how to make the collaborative research group or university side. Also, you have the collaboration with Thailand company side. Also, we have many collaborative research work with Japanese company side. And also, we can make, including the company, both side companies, we can make the large society group, for example, the in welding field or in casting field or in material creation field with company and also the university or institute. I think so. So please come to Japan frequently.
It is a good time, so I would like to talk for in Rajamangala for this time, because we know well Warsaw National Research provide the scholarship about the social and natural side, both sides from submission between Rajamangala or Mahidol from Thailand side and also from Japanese side. However, we have the gap for communication, but in this time, I think we can fulfill some this gap, all right? Then today and this dinner, maybe in the farewell party, so we can discuss with Yamamoto Sensei for fulfill this gap to communicate, to get the big funding from Warsaw, something like that. Okay, thank you very much.
Thank you very much.
Thank you very much for a very informative speech.
And may I invite Dr. Sukit Nitinai, the President of Rajamongkol University of Technology, Krungthep, on stage to present the token of appreciation to Professor Motomichi Yamamoto.